I read about 4 science mandates of James Webb, and one that interests me particularly is planets and origins of life. And I was thinking, do we know the answer? Is life something that nature strives to create? End goal is life almost, or is life something that happens, at least the way we perceive life, as almost a coincidence, almost something that, can happen but might not?
Good question. Well, of course, we don't know the answer to your question because we only have one observational data point, which is Earth.
Yeah.
So what the geologists are telling us from the fossil record is that within a few 100 million years of the formation of the oceans, there are signs of fossil life. So that suggests that whatever it was quick. And if it was quick, then maybe it's not unusual. Maybe it's even what I call a thermodynamic imperative, something that would always happen if the conditions are good. So this is a different idea from what people used to think, because 50 years ago, 100 years ago, people looked at the complexity of life and they couldn't imagine how all that complexity could arise from the forces of nature. But now I think we are driven to consider the possibility that it's a thermodynamic imperative that will always happen whenever it's given a chance.
Yeah, that's interesting.
Yeah. So we don't know, but we have one observation.
Yeah.
And recently was discovered TOI 700D, labeled as in the habitable zone. What does that term actually mean, to have the planet in habitable zone? Is it the conditions to life to exist? Like Luke said, what are the chances of forms actually existing there? Can we ever, in our lifetime, have a means to confirm life existing there?
Good question. Well, what's the term mean? Habitable zone means planets of about the right size and temperature to be like Earth. So if they're too big, then they will not have a solid surface. They'll be more like Neptune or even Jupiter. They'll be a gaseous planet. If they're too cold, then they can't really support liquid water. We think or imagine that liquid water is necessary for life, because that's where we find it here. So it's not, we don't really know that, but it's a good place to look. So that's why we call it the habitable zone, the right size and temperature. The next question is, well, what sort of star should we be looking around? So we have stars like the sun. The sun is pretty big, pretty bright, and Earth is pretty far away from it, 93 million miles, so 150 million kilometers. And the sun is peaceful most of the time. It has solar storms, which we see here on Earth when we get an aurora. But actually, observing an Earth-like planet around the star like the sun is quite difficult because the sun is 10 billion times brighter than the Earth. So that's a huge problem. You can't just build a telescope to see a little faint thing next to a very bright thing. It's very hard. So the other technique that we have is called transit spectroscopy. So if you're fortunate and you know when to look, a planet can go in front of its star and block some of the starlight. And so then you can analyze to see whether you can see any sign of an atmosphere. Does any of the starlight go through the planet's atmosphere on its way to our telescope? And so we know this technique works. We have studied some very large, bright planets, very hot planets this way, and we have even been able to measure what the chemicals are in the atmosphere. There's one where we recently measured it has sodium and potassium atoms. It has carbon monoxide and carbon dioxide. It has water, even has sulfur dioxide in the atmosphere. But this is a planet that's very unfriendly to ordinary life. It's very hot. But it was an easy target. So we know we can try that. And so we will be observing altogether 62 planets by this method during the first year of operation of the Webb. We'll tell you when we find out something that's interesting. I'm sure it will be a great surprise if we can say this is a planet like Earth that has water. That's one of the main targets.
And when we are talking about the life in space, we are talking about carbon-based life. Am I right? But
yes.
What are the odds to have life based on something other, for example?
Well, chemists argue about this, but it's pretty clear that carbon is a better atom than most others, because carbon makes chains and very complex chemistry, and the other ones don't, without a lot of extra help. So chemists can synthesize the most astonishing things, but nature synthesizes things out of carbon mostly. So you could say, well, is that the only way? Well, another thing that could be different would be the solvent. You know, we use water. Everything here that's alive is in water. But what if that's not the only solvent, the only liquid?
We stay genuine, uncensored, and unscripted, and we always will, as we have to order our usual. Share us and subscribe us, and stay tuned until the next Wednesday. Ikuzo!